Hello there, college algebra students. This is Mr. Kashi speaking. With this video, I think we're just going to be doing one video on functions with negative exponents. This is the only example that we'll go through. Obviously, ask if you have any questions. But we have a function here, f of x equals 3x to the negative 2. And we're going to be doing the same process that we have been, plugging in to get some ordered pairs, plotting those ordered pairs, and then talking about the different characteristics about them. So I'm going to start by plugging in our first term, but I want to do just kind of a short little review over here on the side, if we could, of what a negative exponent really is. A negative exponent means that we're actually putting that on the bottom of the fraction. So this would actually be 3 over negative 3 squared. So hopefully you can see how this can, this is actually going to start really small because we're going to have a rather large number on the bottom. So here, once you plug in negative 3, you would be getting 0.3 repeating, or that would be 1/3. And as we go forth here, you'll see kind of how these are all division problems. That's the last one I'll do with that. I mean, really, if you use your calculator to plug in with these negative values and using parentheses properly, you'll get it just fine. So once we plug in negative 2, it'd be 0.7. We plug in negative 1. That would be actually up to 3 because 1 squared, that would be 1, and then we're just doing 3 divided by 1, so we get 3. And here's the thing with this division. So this would be, once we plug in this 0, hopefully you understand what this would mean, 3 over 0 squared. Well, 0 squared is just 0. We can't do that. That is undefined right here. I'll show you what that's going to look like on the graph at the right. Then everything is symmetrical like our parabolas were. So we have 3, we have 1, negative 2, that's going to be 3 as well. Plug in a 2, that's going to be 0.5 again. And then we're going to have a 3 here, and then this would be 0.3 repeating, or 1/3. So if you want to actually plot these, it's actually easiest to start in the middle. So we have that undefined. Well, we're going to have an asymptote right down where x is 0. So our graph is never going to touch that vertical line. It's never going to touch our y-axis. The other points that we have here would be negative 1, 3 and positive 1, 3. Then when we go out to 2 and negative 2, that's 0.7. So 2 and 0.75, negative 2 and 0.75. Then we have 3 and 1/3 right there. So you can kind of see the shape of how this is going to look. It's going to get infinitely close to the y-axis, come down through these points, and then it's going to get infinitely close to the x-axis, like that. Just like that. And we have arrows on all of these. So here we have an asymptote on the y-axis. Okay, and then technically there's an asymptote across the x-axis. We're going to be talking about that at a different time. But that's good to know for this case, taking a look at this graph to determine our domain. Well, our domain is pretty much everything except for when x is 0. So when we plug in x, 0 for x, we get undefined. So it's basically all the real numbers except for 0. And when you write it in interval notation, that means that we're going to start at negative infinity and go up to 0 with a union of 0 to infinity, making sure that we're using parentheses because we cannot include that 0. Range and our intercepts. Range, we obviously start at 0 and go up to infinity. And then our intercepts, we don't have any intercepts. We're not crossing the x or the y-axes in this case. Then getting into our end behavior, our limit, as x approaches negative infinity. That basically means as we're going to the left, what is happening to our graph. Okay. Well, before we were talking about how well it pointed up, it went to a positive infinity. It went down, it's going to negative infinity. In this case, when we're talking about as it goes down to negative infinity, what's going? Well, it's actually approaching 0. It's going to get infinitely close to 0. It'll never touch that, but it's asking, okay, what are we getting close to as we go to negative infinity? And hopefully you can see on the positive side of the graph, as x goes to infinity, as we're going this way, what's happening? Well, that graph is also getting infinitely close to 0. So our end behavior would be 0 in both directions. Then the last characteristic is when is it increasing and when is it decreasing. Hopefully you can see on the left-hand side of the y-axis, this has a trend of going up. So we are increasing from negative infinity to 0. We are not increasing or decreasing at 0 because that is not part of this function. But after that, we cross over to the positive side, the right-hand side of the y-axis. Hopefully you can see how our graph is trending down. Okay, it's going to trend down at different rates, but in general, it's going down the whole way from 0 all the way to positive infinity. It's obviously decreasing very quickly when it's close to the y-axis, and not decreasing quickly when it's close to the x-axis. But overall, that trend is decreasing. So hopefully you understand why I just did a sole video on this when the exponents are negative. It gives us a rational function. And I'll have at least one more video on the radical functions and their graphs and how to solve them as well.